AP6, investigating the contents of an unlabeled container. Sometimes containers in lab or elsewhere end up with no label. When this happens, we need to make sure everyone stays safe and then identify the contents. In this lab, several bottles are found unlabeled. Your job is to identify the unknown. Refer to Table 1 for possible choices. The objective is to identify the contents of a bottle assigned to you, knowing that it can be one of the 20 substances in Table 1. Remember that you need to adhere to lab safety. Some of these substances may cause irritation if they come in contact with skin and eyes. Pre-lab. You are to answer the following 3 questions. One test that can help identify a substance's melting temperature. Use the resources available to text online references to find melting temperatures of the 20 substances in Table 1. When describing whether or not substance will dissolve in a particular liquid, a phrase like dissolves like is often used. Explain the meaning of like dissolves like and offer a few examples. An unknown solid is tested to determine its identity. The first test performed is to add a small amount of the unknown to water. The solid does not appear to dissolve in water. What type of bonding or types of bonding can you eliminate as possible properties of the solid? What might be a good second test to perform on the solid? These are my answers for the AP6 pre-lab. You're welcome to look over them. So I have a table of the melting points, which you will most likely need as you do this lab. Okay, we have to share the melt station, so this is one that you may have to work with other teams so everybody gets access to it. But you're going to learn how to set up your melt station, and you're going to proceed to test your substance in the melt station. This should take you about 10 to 15 minutes at this station alone when you're running your tests, and somebody has to stay there and they have to watch it. So please do not go past the limit on the melt station. If it does not melt within a certain parameter, it means that the temperature is higher than that which the melt station can produce, and that helps you identify which your substance is. If your substance starts melting, start noticing the point at which it starts melting, and then notice when it gets done melting. You're interested in that range, and that range helps you identify what you're looking for. Okay, we're going to connect the melting station. We're going to turn this on. We've not started the heating process. We're doing graphical analysis. We're going to do sensor data collection. Since you're so close to my charging station, you're probably going to come down here and find the one that says MLT. And I want to connect the MLT, otherwise you might connect some of the other probes. And it says done. And I want to be able to see my temperature. Okay, so that's connecting the probe. Okay, the next phase is to get your capillary tube set up as I do. And what you're going to do is you're going to obtain a capillary tube and you're going to obtain your sample. And what you have to do is you have to sit in there and you've got to get some in the tube. And then I have an old burette stick here, and I'm going to drop my capillary tube down a few times, and that helps it to sit down in the bottom of it. I don't need a whole bunch of it. I just need enough that when I'm looking through here, I can see what's going on. So when I have that done, and there are 3 holes back here. So I don't know how well you can see that, but I'm gonna split these 2. So I have 2 going at the same time. We're gonna be looking through here, and this is what we're gonna be watching as we start heating up. And so if we're ready, we're going to start collecting. And now I start heating, and I'm not going to go over 220 is really what we're going to max out at. And so now we're going to be sitting here for a little bit. We're letting it graph. We're going to be watching this eyepiece here, And when it finally starts melting, we're going to note what that is. And since I had two of them going at the same time, I'm going to have to really pay attention to when does one start melting, and then when it gets done melting, and then with the other one as well, okay? Or you can do one at a time. One at a time is going to take you a little bit longer. And that's the melting point station. So a tip, sometimes when you're working on this, you need to twirl the capillary tubes very carefully. They'll help you see if there's any changes with your substance. Okay, so just a friendly tip on how to work with the melting point step. Okay, so my temperature is about 161, and I'm going to see if I can kind of show you what's going on here. I'm not sure you're gonna be able to see it, but we'll give it a try. So, what we're looking at, we're gonna be looking, and again, I don't know how well it's showing up on the camera, but I'm beginning to see a change on my first capillary tube. Okay, my second capillary tube is showing no change. And so we're going to start recording about when we think we saw the change starting to happen, and then when it finishes changing. Once you're done with the capillary tubes, just go ahead and put them in the broken glass. We can't recover those, right? Great job. Is solubility in water. We're going to add a little bit of water to the substance, and we're going to see if we can get it to dissolve. Okay. You could also use universal indicator at that point also to see, is it an acid or is it a base? Or is it neutral? That's also additional information you get. Then you have the conductivity of the solution. You've used the conductivity probes, you're familiar with it. So we can take that solution that we've already made, and we can put the conductivity probe in there and find out does it conduct electricity, and if so, is it a high conductivity, low conductivity? And that helps us point to what it might also be. Okay, we're going to do the solubility test, and we've gotten a small amount of our substance. We're going to connect a temperature probe to, we're going to connect a temperature probe up. We want to see if there's any exchange of energy as we're doing this. The instructions do say small amounts of water. I would recommend that you get your volumetric flask. We want to make 100 milliliters of it. And we're simply going to be filling and looking, filling and looking. So you're going to take your time on this. So I'm going to start, and I just want to see, okay, it doesn't look like it's quite dissolving, so I'll add some more in there. And you keep repeating this process until you get to 100 milliliters. And then you'll stick your temperature probe in there and find out, is there a change of energy? So here's an example one. I've made one of my solutions. I set temperature probe in there, and I'm reading what it says. Okay, and that's why we want the temperature probe with that part of the step. Okay, so this time we're just going to get a reading with our conductivity probe. We've filled 2 clean test tubes halfway up, and we're just going to stick our conductivity probe in there. We're going to get a reading, and we're going to record it. Do for each of the samples you have. So one of the last tests, besides the hydrochloric acid or the sodium hydroxide, is a pH test. And so I'm going to use my pH probe. I've got it connected. I'm going to say done. Again, I just need to know what my reading is. And I'm going to stick it in there, and I'm going to record what it has for pH. Okay? And then I'm also going to verify it with universal indicator. So I'm going to get a pH reading for all of these, and see, that one's different. Okay. All right. use your universal indicator, and we'll just get a reading. And that verifies what I was seeing on with our pH probe. If you've already gone through the test and you've already verified what it is, you don't necessarily need to do HCl and sodium hydroxide. It is just in case you still need to verify what you're working with. That's another way of doing it. Okay? There is no extension, but those 3 tests should not be the only thing you have to do. I would recommend you might want to use the pH probes and test the pH. So instead of just relying on your universe indicator, also get an actual pH level. You can also use the hydrochloric acid that'll be available to you, or the sodium hydroxide. And you can also use, I'll have some kind of non-polar solution for you to test. You should have at least 1 or 2 additional tests to run to try to figure out what it is. Your job is to figure out what's in the unlabeled container. Make sure that you have the supporting material. You're doing basically a CER on this lab. Sample data. So this is some sample data that I have for you. Visual observation, again, you always start with your appearance. This substance was a white powder. So are a lot of other things. But it does rule out sulfur, copper chloride, copper sulfate. Those get ruled out. Melting temperature. So after doing the melting temperature test, I find out that my range for the substance to begin melting is 123 to 126. Okay. And that's the graph up there too. Solubility in water, I pulled out 0.1 grams of unknown and dissolved partially in 100 milliliters of distilled water. After about 2 minutes of stirring, there were few flecks of undissolved solid visible. Then the conductivity probe gave us a reading of 221 microseconds per centimeter, which indicates a presence of ions in solution. So based on the 4 tests, I conclude that benzoic acid matches with the melting point. Benzoic acid is also slightly soluble in water, and the conductivity matches with that. So, and if I wanted to, I could do additional tests and use the pH probe or universal indicator. Okay, that concludes your lab. Hope you figure out what the unlabeled substance is. I would recommend also comparing with other groups. Live long and prosper.